Is AI-generated code silently undermining the stability of the operating systems that run the entire world? Are we about to see a massive wave of production-breaking regressions in the upcoming Linux 7.1 release, all because developers are letting machines do their thinking for them? If you run Linux on your servers, your development machines, or even your personal desktop, these are the questions you need to be asking right now. In this video, we are going to look at why Linus Torvalds, the creator of Linux, has officially lost his patience with AI-assisted development. We will unpack the warning he just issued to the entire open source community. And by the end, you will understand why a bloated release candidate is not just a developer headache, but a massive systemic risk to production environments everywhere. If you have been following the channel, you know we track the health of the Linux ecosystem very closely. But what is happening right now, behind the scenes of the 7.1 kernel development cycle, is unlike anything we have seen in the last 20 years. It represents a fundamental shift in how open source software is written, reviewed, and maintained. And as we will see, it is creating a massive bottleneck for the small group of human maintainers who actually keep the lights on. These are the experts who ensure the kernel remains the backbone of modern technology. But before we dive into the drama, we need to understand the basic mechanics of how a Linux kernel gets built, and why a single release candidate can cause so much anxiety for someone like Linus Torvalds. Let us look at how we got here. It is time to look under the hood. To understand why Linus Torvalds is so annoyed, we first have to understand the rhythm of kernel development. The Linux kernel does not just get updated overnight. It follows a highly structured, multi-week cycle that has been refined over more than 2 decades. It all starts with the merge window, a 2-week period right after a major stable release, where developers submit massive pull requests for new features, new drivers, and core architectural changes. Once that merge window closes, the code is locked for new features, and the release candidate phase begins. This is where the stabilization happens. Over the next 7 to 8 weeks, Linus Torvalds releases a new pre-patch or release candidate every Sunday. The goal of these RCs is simple: find bugs, fix regressions, and make the code progressively smaller, quieter, and more stable as we approach the final launch. By the time you reach release candidate 5, the major issues should be completely ironed out. The code churn should be dropping off a cliff, and the weekly patches should be tiny. But when Linux 7.1 RC5 dropped on May 24th, 2026, it was abnormally large. Instead of a quiet, stabilizing release, Torvalds found himself looking at a massive wall of code changes. In his announcement mail, he noted that the update was pretty big and much larger than traditional RC5 releases have historically been. He openly admitted he was not entirely happy about it. This raises an obvious question. Why is the code expanding at a stage where it should be shrinking? The answer lies in a major technological shift that has taken place over the last 6 months. Chapter 3 of 10. The 20% inflection point. For nearly 20 years, since the Linux project migrated to Git back in 2005, the volume of code contributions per release cycle remained remarkably stable. Maintainers knew exactly what to expect. But about 6 months ago, that predictable pattern completely shattered. Speaking at the Linux Foundation's Open Source Summit North America in May 2026, Linus Torvalds revealed a shocking statistic. Over the last 2 major kernel releases, the development team has seen a 20% increase in commits compared to the historical average over many years. 20%. In a project as massive and mature as the Linux kernel, a 20% spike in code volume is absolutely unprecedented. Initially, Torvalds misread the situation. He thought people were just excited about the major version change to 7.0 and were rushing to submit their work. But he was wrong. The real driver behind this sudden explosion of code was not human excitement. It was the fact that generative AI coding tools had finally crossed a critical threshold of capability, and developers all over the world were beginning to use them en masse to write and review kernel code. This brings us to our first open loop. If AI tools are so good at finding and fixing bugs, shouldn't a 20% increase in code contributions be a good thing? Shouldn't the kernel be more stable than ever? Well, as we are about to see, the reality of AI-assisted development is far more complicated and far more dangerous than the marketing brochures suggest. To understand why more code does not equal a better kernel, we have to look at what is actually inside that 20% spike. When Linus Torvalds analyzed the massive wall of patches in 7.1 RC5, he discovered that the vast majority of the bloat was caused by what he called totally trivial stuff. This massive wall of patches was roughly 50% drivers, with the rest split between networking, file systems, and core architecture. But a massive portion of these patches consist of trivial, non-critical fixes triggered by AI automated scans. These were not critical bug fixes. They were minor cosmetic changes to long-standing, low-impact issues. Things like spelling corrections in code comments, minor formatting adjustments, or redundant null pointer checks. These are issues that have existed in the kernel for years without causing a single problem, and they certainly did not need to be addressed late in a release candidate cycle. But why are developers suddenly submitting thousands of these trivial patches? Because AI code review tools are incredibly good at scanning massive code bases and flagging every single theoretical violation of style guides or minor coding standards. A developer runs an AI tool over a driver. The AI spits out 50 trivial fixes, and the developer immediately packages them into a pull request and sends them up the chain. Torvalds refers to this as pointless churn. It creates a massive amount of noise in the development pipeline, forcing human maintainers to review, test, and merge thousands of lines of code that add absolutely zero functional value to the operating system. But the problem is actually much worse than just wasted time. In kernel development, even the most trivial change carries a hidden systemic danger. In production environments, there is a dangerous misconception that small, simple code changes are inherently safe. We see this all the time in enterprise IT. A vendor releases a minor hotfix or a trivial patch, and because it only changes a few lines of code, we assume it cannot possibly break anything. But in the world of operating system kernels, there is no such thing as a safe patch. Linus Torvalds made this point crystal clear in his warning to developers. He noted that while trivial fixes have a very low chance of causing problems, a low chance is still not a zero chance. When you multiply a low risk by thousands of unnecessary patches, the probability of a major regression sneaking into the final stable release skyrockets. Every single line of code added to the kernel, no matter how simple, must be compiled, linked, and executed across thousands of different hardware configurations. A trivial null pointer check added by an AI tool to an obscure hardware driver might seem harmless, but it could easily trigger an unexpected race condition or a memory leak on a specific enterprise server architecture. This is why submitting non-critical, old bug fixes during the release candidate phase is so dangerous. The RC phase is designed exclusively for fixing regressions, new bugs introduced by recent changes. By flooding the pipeline with trivial AI-generated fixes for old, stable code, developers are introducing completely unnecessary risks at the worst possible time. And as we are about to see, this AI-driven flooding has already crippled one of the kernel's most sensitive communication channels. Chapter 6 of 10. Clogging the security pipeline. The most alarming consequence of this AI code scanning boom is not happening in the public Git repositories. It is happening in the confidential channels where critical security vulnerabilities are reported and patched. The Linux kernel security mailing list is a highly restricted private channel. It is designed for researchers to responsibly disclose severe zero-day vulnerabilities. This allows a small, dedicated team of core developers to quietly write and test patches before the exploit becomes public. But over the last few months, this vital pipeline has been completely overrun. Because AI tools have made it incredibly easy to find potential security bugs, thousands of amateur researchers and automated bots are running the same scanners over the kernel source code. When the AI flags a potential memory leak or a buffer overflow, the user immediately forwards the raw AI report to the kernel security list. They're often just hoping to get credit or an official CVE designation. The result is what Linus Torvalds describes as enormous duplication. Because everyone is using the same commercial AI tools, they are all finding the exact same bugs and submitting the exact same reports simultaneously. The core security team, which consists of just a handful of extremely busy human developers, is now spending almost all of their time manually sorting through these. They are verifying and forwarding thousands of duplicate AI-generated reports instead of actually writing security patches. This is a massive bottleneck that threatens the security of the entire open source ecosystem. Chapter 7 of 10. The new rule of AI disclosures. To combat this overwhelming flood of duplicate AI reports, Linus Torvalds has officially laid down a new, blunt rule for security disclosures. It is a rule that every security researcher, developer, and sysadmin needs to commit to memory. If you find a security bug with AI, you should basically consider it to be public. The logic behind this rule is simple but profound. If you use an AI tool to scan the Linux kernel and find a specific vulnerability, you must assume that at least 100 other people have run the exact same prompt, used the exact same model, and found the exact same bug. There is no longer any such thing as a private or confidential discovery, when a commercial AI model is the one that found it. By declaring these AI-discovered bugs as immediately public, Torvalds is stripping away the incentive for researchers to clog the private security mailing list with automated reports. If it is public, it should be discussed in the public bug trackers, not sent to the confidential security team. This rule represents a major shift in the cybersecurity landscape. It forces us to redefine what a vulnerability disclosure actually is. But it also highlights a deeper, more systemic issue in the tech industry. The growing divide between the people who generate automated code and reports and the people who actually have to maintain the systems. Chapter 8 of 10. The Vibe Coding Reality Check. We have all seen the sensational headlines and the aggressive marketing campaigns from tech companies claiming that AI is going to completely replace human programmers. Some startups even brag that 99% of their code is now written by AI. But when Linus Torvalds hears those claims, he does not get excited, he gets angry. On one hand, we have maintainable production code, written with human understanding. On the other, we see what is being called AI-generated work slop, a chaotic pile that lacks structure. Speaking at the Open Source Summit, Torvalds did not hold back. He said, "When I see people saying, hey, 99% of our code is written by AI, I literally get angry." He pointed out the absurdity of these claims by comparing them to compilers. Technically, 100% of our code is written by compilers and assemblers. But we do not claim that compilers are the ones doing the programming. AI is a tool, an incredibly powerful compiler of human intent. But it does not replace the fundamental need for human understanding and judgment. Torvalds estimates that AI can easily increase a developer's productivity by a factor of 10. But it does not change the core reality of software engineering. If you do not understand the code your AI tool is generating, you cannot maintain it. And in a project as critical as the Linux kernel, unmaintainable code is a death sentence. This is the Vibe Coding Reality Check. Generating code is easy. Maintaining it for the next 10 years is where the real work happens. And this is where the SysAdmin Perspective becomes so critical. Chapter 9 of 10, the SysAdmin Perspective. As someone who has spent over 25 years in IT administration and support, I look at this entire AI code explosion through a very specific lens. The production lens. In enterprise environments, we do not care about developer velocity or how many commits are added to a repository. We care about uptime, predictability, and stability. Let's compare developer velocity against sysadmin stability. Notice how AI-driven code generation increases velocity but actively threatens stability. It introduces regression risks and patch fatigue. From a sysadmin perspective, this AI-driven code explosion is a massive red flag. When developers flood the kernel with thousands of trivial patches, they are actively increasing the regression risk for our production servers. Every unnecessary patch is a potential point of failure. We are already suffering from massive patch fatigue. In the last 3 weeks alone, we have had to deal with 3 separate kernel privilege escalation vulnerabilities. Copy fail on April 29th, Dirty Frag on May 8th, and now Fragnesia on May 18th. Each of these required emergency patches and system reboots. The last thing we need is for the kernel development pipeline to be clogged with trivial, non-critical AI slop that delays actual critical security fixes. We need a kernel development process that prioritizes quality and stability over sheer volume. We need developers to stop treating a kernel as a playground for their AI experiments and start thinking about the sysadmins who actually have to deploy and maintain this software in the real world. So, where do we go from here? The warning Linus Torvalds issued. With the release of Linux 7.1 RC5 is a necessary wake-up call for the entire software industry. He has made it clear that going forward he will be far more hard-nosed about pushing back on pull requests that contain unnecessary late-cycle churn. If a developer submits a patch late in the cycle, they must be prepared to answer a simple, critical question. Is this really a regression? If the answer is no, that patch is going straight to the development pile for the next version of Linux, where it belongs. AI is not going away, and it should not. It is an incredibly powerful tool that can help us write better software, find real bugs, and automate tedious tasks. But we must treat it as a tool, not a replacement for human discipline and responsibility. We must prioritize quality over quantity, stability over velocity, and human judgment over automated churn. Make sure to like this video, subscribe to the channel, and sign up for our weekly newsletter at tondelslinux.com/subscribe to stay ahead of the curve on everything happening in the world of Linux and enterprise IT. Consider clicking the join button below to support the channel directly as a sudo user or root access member. Thank you for watching, and I will see you in the next one.